idea you were starting.
One of us is more prepared for this
So
podcast than the other
I
one.
forgot we were even doing it, and you just like started like that. Oh man.
I gave you an hour warning. That is
I
not my fault
forgot.
you forgot.
Forgot. I'm hungry. I haven't eaten anything. I need to like grab something to eat. Seriously.
Whose problem?
Whose problem? That's my problem right now.
It's the podcast problem. Well, in this moment, in that case, I will do the Patreon spiel now instead of at the end. As you know, I was going to save it, but let's do the ad read. And this awesome live stream podcast show, what have you, is brought to you by listeners such as yourself and some patrons here and there. So this concert, this discussion is brought to you by listeners such as yourself. You can support this episode directly on Streamlabs, and the link for that will be on the screen. For those of you who are listening to this audio only, it is streamlabs.com/Anna Cherry. As for, me, Anna Cherry, and my other half, Richard Rawl, who's getting something to eat. Because I sprung this episode on him with that whole hour's warning. I sprung it on you this episode.
Oh, oh, the actual start there. Suddenly I hear and start.
Well, when we have random music coming from the speakers, it's usually because we have starting soon. That cat is
There's
just.
always starting soon in this house.
It's true. And you're usually involved. So, for those of you who want to support us on Patreon, you can help us hit the next milestone, the podcast hosting. And that would be really cool to turn us into a real boy podcast on iTunes and Streamlabs and Google Play and what have you. Now, if you can't support us monetarily, that's okay, because you can share this with someone you think will find this topic interesting. And more importantly, subscribe is just a click of the mouse for you, but for us, it helps us a lot. It makes a big difference. So if you choose Patreon, definitely check out Challenger Level. It is as safe for work as you can get while still supporting this Patreon, this stream with your Patreon pledge directly and getting some special stream CherrySTEM podcast related rewards. With after show access to bonus content and Q&As and other cool stuff. So check it out. All right. Now, as for our topic,
Yes, what is our topic?
that is actually pretty humorous because the topic that I have, the content or the resources, I guess, for this one is just a bunch of your answers on the topic. So
Oh, okay, cool.
it's sort of, it's not meant to be an interview. It's just you happen to be the current one and only expert on this topic, as far as I know, and as far as most people here know. So we're going to be talking about quantum computing.
Oh my god.
Food.
I was just literally writing to somebody who's at the bleeding edge of quantum computing right now. There's some developments. Okay, so Google just recently came out with this article they called. Well, it wasn't really Google, but it was it's related to Google. Anyway, it's called quantum supremacy, and the idea. This only came out like I guess like a week ago, like that.
About a week ago.
The point is, quantum computing up to this point hasn't really proven itself to be, like, physically proven itself to be superior to regular computational methods.
Right.
Now, I mean, there's a couple of different directions I could go here because the other thing I want to mention real quick while I'm thinking of it is that I also recently shared an article on how the free body problem, which has to do with computing things like the path of both the sun, the earth, and the moon, instead of just two bodies, has been something that's been long-standing. It's a really difficult problem to tackle computationally, and they've gotten a 1,000-fold increase in speed by just using a deep neural network, and that's something that's been fairly recent.
So what about
now, why would neural network and quantum computing be directly related? Well, for a number of reasons, because of something that I call holographic computing. Yes?
You started with the Google.
Okay, so yes, I was getting to that. It's just
it's
a really broad subject.
Exactly.
Sorry.
So I do have a.
You have specifics that you want to hit.
Yeah.
Okay, cool. So yeah, I was just talking with Gianfranco Basti. I think I don't know if that's the right. Anyway, he's there's one of the lead researchers in quantum computing in Europe. Is him, and I don't know if I'm pronouncing his name at all correctly, even in the slightest. And the way that they're doing it is completely different than what Google's doing it. But what it comes down to is something I've been screaming on the internet, screaming into the void for years and years and years, and that is that the only way to actually do quantum computing is analog computing.
Right. So we'll get to that.
Okay.
Because in order to understand any of that, we got to give ourselves at least a half hours of runway as to what is even any of that. So, I mean, we're talking about like educating noobs.
Okay, cool.
Which of I am one myself. So, I was looking into this whole what is quantum computing? Like having to talk about this on today's stream, I had to at least try to figure out what the heck we're talking about. And there's even YouTube videos on it, quantum computing explained, and all this other stuff. And you yourself, of course, have a. Can you explain how does quantum computing work in one paragraph? Where you mention what you just did about analog digital computing hybridization, but also fact that at the moment, and this was, mind you, in 2017, that at the moment, quantum computing is a weasel word that is a nonsensical pipe dream. However, just recently, I was finding this article where it's like scientists, something about.
Oh yeah, I was talking about how back when D-Wave was coming out, and they're like, oh yeah, this is like they did it. No, they didn't. They didn't do shit. But they did. And I was saying that when D-Wave came out, like, nope,
but yeah, they were talking about how there's like, now they're talking about how the quantum computing extended by 50 kilometers. They can, there's, I don't know if that's it or not, but there's a lot of news coming out about like quantum computing recently. So that's what sparked sort of this interest.
Okay, so let me talk about what the difference is between real quantum computing and bullshit quantum computing.
Well, to begin with, what is even quantum computing at all? Because as I was looking into it, they were talking about, one of the quotes is that you can't build a light bulb by making better and better candles. The idea is that it's, and this has been echoed in other talks too, where it's quantum computing is a utterly different kind of computation that is completely different than the current system that we have, hence the light bulb and the candle, where it's like you can't keep improving the current system and hope to arrive at that one.
So where it came from is people believing in
Feynman
magic.
was involved at one point. They name dropped that the Feynman is like somehow involved in this. Then of course it all rests on qubits, which are quantum bits, and they're saying there's sometimes one, sometimes zero, sometimes both, and then they apparently use some MRI machine to flip charges and then measure the echo of, like, what is even fuck happening? Can you explain this to me, please? What the hell? And then yeah, they're still talking about how it's superposition fluid, but also not fluid. And I do have a TED talk that if we want to listen to that first, or if you want to go first.
Yeah, let me give a couple of preambles to TED Talk, etc., and we'll get and let other people explain, but let me give some perspectives before they give their explanations, so that my when I have refutations of certain things and when I argue with certain things, it'll sort of make sense. and people can kind of expect it. But all right, so
there it is. Entanglements have over 50 kilometers of optical fiber.
Yeah, whatever.
That was in August 2019, like end of August.
Yeah,
so August 29th. So this was literally 2 months ago where I'm like, oh, for fuck's sake, we got to talk about quantum stuff.
Yeah. All right. So first off, there is a tremendous amount of magical bullshit claims in quantum, and then there's real stuff that really physically works and you can fucking engineer off of it.
Hence why I find
and the two of them are extremely interwoven. In other words, there are people. First off, anytime somebody's calling bullshit on quantum, you know, the first thing that's going to happen is somebody's going to be point to, hey, we do real things with quantum. Yeah, that's true, but there are things you can do with truth within limits. Okay, so I guess I first need to cover that. So there's a tribe in Papua New Guinea.
We've talked about that.
I know. I just need to do it again real quick here in this context.
Oh,
it's necessary to repeat things.
Okay.
This
I know,
is how teaching
but
works.
I understand
it's
that.
a
It's just
I know.
we're talking about quantum.
I know, and this is necessary.
Okay.
Trust me, this is necessary. I know you don't want to ever say the same thing twice, and that is just not how teaching works. All right, so
that explains why I'm a sucky teacher.
So there's a tribe in Papua New Guinea who prays to the spirit of the fishing tree. They do a little dance and say some words, and the truth is that and then they say that the spirit of the tree brings them fish, and they replicate this, so it's kind of a replicable science, and we can see that it actually works. They do their little ritual, and fish come to the surface. Well, part of the ritual happens to be that they beat a root into water, and so they are able to use their theory that there is a spirit in a tree who helps them gain fish, and in a way it has a truth within limits to it, and that is that there's a neurotoxin that is not that does not harm people but does harm fish in the root itself. Now all the rest of the bullshit surrounding it, the idea that there's a spirit in the tree that comes out, well, it's almost a truth. You can kind of see it as a spirit, but the truth of the matter is that it is a very limited way of truth. And now in the philosophy in the 20th century, the idea is that that one truth, if it works, is just the same as another truth, is complete bullshit, because it has to do with extensibility. The truth that it's a neurotoxin means that we might be able to use that specific neurotoxin in that tree for the treatment of various types of illnesses with neurological symptoms, etc., whereas they cannot extend. Yes, postmodernist idea is that if two different ideas, two different perspectives of a thing equally represent it in a certain way, then they are equally true and they're equally valid and valuable. And I'm saying that's false, because there is an extensibility to something that is a better, greater truth, and it is a better, greater truth. That it is a neurotoxin because we can develop more from it. We can predict more from it by knowing that it is actually a neurotoxin and what a neurotoxin is. We gain understanding, and exactly what understanding is very closely tied to AI and the development of quantum computers, etc. But we won't get into that at this moment. But it does. I'll say right now, it does have to do with holography. So anyway, so going back to the spirit of the tree, the spirit of the fishing tree, etc. You can, if they might actually even be able to extend it slightly, because when it comes down to it, bees and various types of insects are more sensitive to neurotoxins, it turns out. And so therefore, if they were to try to go, use the spirit of the fishing tree to get to get honey, they might actually still, within the how they understand it, that it gets them food in some way, they might be able to actually even extend their theory slightly and get positive results and replicable results, and and be able to use it in a semi-scientific way, in a proto-scientific way, I suppose I could call it. But if they went out and tried to wave their roots at some deer, etc., they're going to fail miserably, and it's because they're searching in the wrong area. The reason they're searching in the wrong area is because they do not understand what is really going on, because of their faulty perspective on it. It's a truth within limits. Quantum physics. Quantum physics is a truth within limits when they talk about probability, and that is a claim that. What I'm saying is that when they use probability to represent something, probability is a real valuable thing. Right. In other words, if I sit there and talk about the probability that people are going to be, I can set up probability densities to represent people walking along streets. Okay, I can then use that to and even though it can't tell me the real truth about a single one of those individuals or where they are at any given time or anything like that, it is still just the probability densities alone are still a valuable tool.
Right.
Okay.
Statistics are valuable.
They're valuable within a certain limit. And that's true of the way that we view quantum mechanics.
So
but the problem is Copenhagen interpretation. Yes?
So what you're saying is...
Oh, sorry. I just have to get a lot of stuff out quickly.
But don't.
Okay. Go ahead.
Do the opposite.
I have to. You have to stay. You have to keep the context and the thread of all of how all this fits together is very difficult.
Okay, we'll go step by step.
Go ahead.
Small. Babies.
Baby steps. Okay, go ahead.
Explaining to toddlers.
All right.
So what essentially you're talking about is by the probability, because I'm sure many are wondering how we went from Papua New Guinea potatoes to fish or whatever to this. But what you're talking about probability is what you're essentially is superposition.
It's related to superposition.
There is superfluid, quantum position, all of this stuff they talk about that a lot, and nobody knows what that means.
But it's provocative.
Do I play the TED Talk video that's supposed to explain it, or you wanna
Okay, I had a resolution. Quantum. I was trying to get to a resolution quickly, and that is that there is a bullshit idea about quantum mechanics that is specifically that reality.
Mechanics or quantum?
Quantum physics. There's layers. Like quantum field theory is like probably the highest form of accepted quantum, mechanics right now. But quantum mechanics, quantum physics. Basically, there is a Copenhagen interpretation, and there's the three different interpretations that are the main competitors. Pilot wave, which most people don't even know about and think it's like this thing that's deprecated. You don't even need to talk about. Yes, pilot wave interpretation is the superior one.
But I thought that was with the
yeah, silicon oil drop experiments. Yes, that's a
no. That it has to do with the particle duality.
It does. It explains how that works.
Right. So what does that have to do with quantumness?
Okay, all of that's quantumness. Every bit of that. God. Okay, so that is all quantum physics. Okay, the idea that a particle and a wave are a singular entity, the dual slit experiment, all of those things are one set of ideas explaining the physics of the extremely small at the atomic and below level. So, subatomic particles specifically. So where was I? Doggone it! I had a thread that I'm kind of losing here. There's Copenhagen interpretation, which basically presumes that reality at its base is made up of probability. Probability of what? It's kind of like, okay, part of why one of the problems that I usually have is that you actually do need to go all the way back to relativistic physics, because that's what kind of spawned quantum physics in a way. A lot of people don't know where that connection is, but it is directly connected. And one of the problems is like the belief that a wave can exist without a medium is a huge problem. And so that mental problem actually continued into quantum physics and made it where we believe that probability can happen without events. There is a this disconnect between the model and that which is modeled. In other words, the map and the territory are conflated constantly now in physics. That's the biggest problem of the 20th century, is conflating the model with that which is modeled. And so there is this disconnect, and there's in relativistic physics you're not even allowed to talk about that there are alternate interpretations, and there's Lorentz Poincaré ether, and then but then going from there to 20th century, there's basically been this competition between many worlds and Copenhagen interpretation when it comes to determining what the hell is going on with all this probability stuff. So what is superposition? Superposition
somehow important
is this idea that a particle exists in many different states at once. And so you've got, and then when we measure it in Copenhagen interpretation, the idea is that when you measure it, it is not just the physical act of measuring it that causes a physical thing, but specifically that it was in many states and it gets reduced down to one state. So it went from being probable to being extant. It was like literally in one place. And so the two different ways of viewing this that kind of competed the most, and where they just kind of ignored pilot wave because they didn't really understand it. And that's the truth. They think that they thought they didn't understood it, but they didn't. And it's only really been well understood in the past 10 years by John Bush at MIT because of the Coude Silicon Walker experiments. That's put us miles ahead in pilot wave. Just a gigantic fucking leap forward.
And but so what we're saying is that versus the pilot, the particle and a wave duality, it was the explanation for quantum stuff before, and didn't really get us anywhere.
Well, it's not just particle wave. Wave particle duality actually does exist because, and I'll tell you this, in fluids, there is, okay, let's go to the Walker experiments, because whenever we're talking about quantum physics, it's always best to drop back to the Silicon Walker experiments, and you can Google that if you like. But it's, and so there is a way in which that little droplet bouncing on the surface exists as both that droplet and the wave. It can't. It would rejoin with the rest of the bath. It would no longer exist as a separate thing if it did not have a wave that was continuing to make it bounce. And another example of a duality, there's something called wave vortex duality, and that is in a fluid. As a wave passes, like so, are you familiar with the idea of a standing wave, where just a wave seems to just bounce up and down in one place because the way the waves. Well, what's happening there is like if you've ever seen a standing wave, usually it's because you've got some enclosure that the waves are bouncing back and forth, and you've reached the right frequency to make various waves move up and down in place instead of propagate. They are actually propagating. It's just they're crossing each other perfectly in a certain way that makes it look like they're standing in one place. So when you create a checkerboard of waves, of standing waves in a square wave pool, what will be there underneath those waves that you're seeing is vortexes. Okay, there will be if you have a checkerboard of those standing waves, you will have a checkerboard of alternating vortices also in that same place, because when you're talking about physical waves, as waves pass through each other, they don't just crash into each other and bounce off. They pass through each other. How do they do that? Through rotations. Okay, so that the physical medium is rotated as the waves pass through each other. So that's the reason why you have something called wave vortex duality. So there are different types of dualities that have to do with just mechanics. There are requirements, and that both of those different, the idea of wave particle duality and what I've just explained to you is actually a very crucial part of understanding how it is that pilot wave is the superior model of physics. There's a lot more to it, but we won't go into all that, because what we're trying to get to is what is the difference between bullshit quantum and real quantum.
Because if quantum computing is based on
so
here's the thing. Then yes. Is it based on the wave particle duality, or
it is?
It seems like that explanation.
It is. Okay,
or the
so
theory
here's the thing.
Is at the root of.
So here's the thing. The way in which they first started talking about. So first I'm going to tell you the bullshit version. Okay. So the way they first started talking about it, you had many worlds interpretation where, okay, so there's so at any given moment, any particle that hasn't been observed is splitting off into infinite universes. Like literally we're just branching out into these infinite universes all the time for every single particle at any given moment that you want to slice it up. The state of that particle represents, because it's superposed into all these different possibilities, that spawns another universe. And so there's like infinite universes being spawned at an infinite rate. It's just fucking ridiculous.
But that is theoretically a deterministic one because you end up in the universe of whatever it was that you happen to have observed. And so that's the many worlds interpretation. You've got these, infinite universes being created in the most infinitesimal moment. And then, but then what Copenhagen has is that, well, the particle exists in this fuzzy probability state, and it doesn't actually really exist as anything other than probability until you observe it, and then at that point it becomes a particle. And so that's one of the reasons why that's one of the reasons why Einstein said I'd like to believe that the moon is still there even when I'm not looking at it. So all this gets back to what was the first bullshit idea of quantum physics, and of quantum computing, and that was basically we could exploit the fact that there are all these infinite universes and shit like that we could just like do. It was just a very magical way of looking at it. Just terribly ridiculous. Yes.
Are you serious?
Yes, I'm dead serious.
Are you serious?
Yes, it's
quantum computing.
It's totally just
a bunch of sci-fi geeks.
Just sci-fi woo bullshit. It was the first ideas of
quantum. A bunch of fucking sci-fi geeks were like, let's do computation in the subspace, man.
Yeah, no, it was complete bullshit.
Oh, that's adorable.
Now the level at which there is a vague truth to it is this. The best way I can explain this to you is by trying to give you a visualization. And a visualization of how you could use sets of probability to come to a calculation-based answer. So think of a ball I could throw down a hallway, okay? So if I throw a ball down a hallway, the shape of that hallway is going to impact the way that ball comes out the other side. That is, in essence, sort of computation. Okay, it is. There are changes happening to something based on a shape. That's the way that Babbage's difference engine and those first mechanical computers actually worked, is based on shapes and mechanical interactions. And so there you can represent computation in this way. So if instead of a ball bouncing down a hallway, imagine that. So with quantum physics, the idea is you have these areas of probability that are probability density. So it's like a map of. It might as well be like after you've run a bunch of ping pong balls through a plinko machine. Down at the bottom, you've got like a little wave of where some more of them are in the middle and less of them are on the sides. If you've ever seen the outcome of a plinko machine, plinko machine, it's got the little rods that you drop something and it goes bounce, 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 and it's like there's like a pyramid of like little rods that it falls through, and you hope that it goes into one of the,
That's like a game, isn't it?
Yeah.
What colors?
Well, I don't know. You drop a ball in and it goes through some rods, and basically it randomizes it. But there is a probability distribution that you will see if you continue to run that over and over and over. The balls will pile up at the bottom, and they'll be more likely in the middle and less likely at the sides. But it's dependent upon the little rods that it has to go through. Yes, right. So,
bell curve distribution.
Right. So there are that's a probability density. That's like a map of a probability density. So that it has a shape to it. And so what has happened is there are over many computations that there is a probabilistic outcome that you can kind of use this in computation. And so instead of throwing a ball down a hallway, what I can do instead is throw a ball down throw a hot dog down a hallway. Instead of throwing a ball down a hallway, what I can do is if I change the shape of that hallway, now the way in which I've changed the shape will alter the course of even I've got a perfect throw of a perfect ball in exactly the same way. Every time I change the shape of the hallway, the outcome of where that ball will end will be changed based upon the way that I change the shape of the hallway. So what I'm trying to explain here is that you can use probability densities as a method for calculation. So in other words, so you think of it as like a cloud connected to a cloud connected to a cloud. If a beam of light is trying to pass through and it only say it's like a cloud of little mirrors or whatever instead, and so it can constrain the light in a certain way so that it travels down this pathway of these shapes, and it will make it come out the other way in a certain pattern. So there is a way in which you can, within a limit, gain computational power from probability, is what I'm trying to tell you. So there are ways in which using the randomness that we see, it's not really random, it is probability densities that we see in quantum particles, you can then use that as a method of computation. So that is a real methodology of doing it. However, it is exploiting that in a way that makes it more powerful that is the difficulty, and that's where it hasn't been proven until just recently that you can actually use a quantum system to solve a particular problem in a method that exceeds normal computation methods. So that recently, that was Google's quantum supremacy announcement. I don't know if it was specifically Google. That's just how I refer to it because that's how it's referred to in my group. But it's the quantum supremacy announcement that recently came out with this chip. Is basically, it is an announcement that quantum can be superior to regular computation. That is the claim, and that's only, like I said, only about a week old. And so that is the first time it has actually been proven. And the way that they did it, however, is not using any of those magical ideas that people had of quantum physics, but instead exploiting wave computation. So wave computation, now if you think about this for a moment, if I have a wave that I like on a pool, and I just, well, actually, if you just like smacked a pool a couple of times, if you do it once, you got one nice clear wave, right? But if you do it a few times and in a few different places, all you got is just a pile of weird little ripples all over the place, right? Well, each of those ripples is actually the outcome of individual waves with other individual waves, and it can break it down into smaller and smaller pieces. And so you
could track the math if you want.
Yeah, well, if you're trying to doing our normal computation to try to figure out what those waves do is actually putting the cart before the horse, and that is the waves themselves are computing, and so they are doing something. And so one of the problems that we've had in the past is how do we then model what nature is doing, because that is a method of computation that is far superior to the way in which we are doing things, because it's massively parallel, and so trying to do that, that is, previously we had regimes of analog computation that weren't exactly the same as that, but it is the use of that system of analog interactions that can lead to a regime of computation that will be far superior. So now that you know that that is the real way in which quantum computing will actually end up working, because there is a real wave nature to particles, and then at that level you can exploit that extremely small level and reliable ways that they will interact in some way to allow waves to do this analog computation, and then being able to test the outcome of the wave interference patterns will give you a method of computation, okay? Right. And it'll give you a very precise method of computation as well, which is not what you would normally do from the would not normally get from the probabilistic method I was talking about before, with throwing the ball down the hallway and shaping the hallway. That's a probabilistic method of computation, where you're just basically kind of confining what the outcome is over many iterations. And but what I'm talking about is that's the two different ways in which they are attempting to solve the problem of quantum computing.
How do you do that if complicated?
Yeah, it's we'll get to that. Yeah, well, that's what they're doing. Yeah, it's not something you can easily just kind of come up with here. Yes, you're right. That is very difficult. That is extremely difficult. That's the reason why that is like the world powers are interested in this right now. Okay, this is actually, some people are afraid that if we have some sort of asymmetry in the development of quantum computing, and in other words, like China gets it before the U.S. and is able to implement it and use it, and or any one country can get it before the others, that they will instantaneously crack all of the codes, etc. for God damn it, security, every type of security, and so all of immediately the first. Okay, here's the thing: the first place or people or to actually create quantum computing on a large scale that is very, that works, will almost instantly crack and destroy the entire, global infrastructure for economics. And so that is, and economic warfare is the primary method of warfare in the modern age. So therefore, this is related to
highest levels of.
Yes, right. So we should listen to the TED Talk at this point, so that people understand exactly what's at stake, and that there are two different real regimes that are very much being. And it's analog computing. Now, the analog computing, that's where people are actually seeing in Google quantum supremacy. It's all about analog computing, just like I've been saying for a very fucking long time.
It's 2017 on record.
Oh, it was way before that. That's just the one that I found.
I mean, on record.
Yeah, on record that you found. I guarantee you can find others from like 2014 or earlier. But so that is the actual quantum computing. That's where quantum Google's supremacy announcement came from. Their new chip, the way that it works, is based upon analog computation and being able to control and measure that analog computation. And then like I said, I was just talking with somebody else who's doing it through an all optical method. All optical method is, I think, may have more promise than some of these other methods that are much more difficult, but they each have their own limitations. So anyhow, yeah, go ahead and play that video. So we've got an introduction that'll kind of go back over some of the things I've just said and maybe clarify some things if they weren't clear.
And we definitely have some talk about optical stuff.
Yeah. Oh, absolutely.
It seems like magic or cheating, but actually it's just quantum physics in action. Here's how it works. A regular computer simulates heads or tails of a coin as a bit, a 0 or a 1, or a current flipping on and off inside your computer chip. A quantum computer is completely different. A quantum bit has a more fluid, non-binary identity. It can exist in a superposition or a combination of 0 and 1, with some probability of being 0 and some probability of being 1. In other words, its identity is on a spectrum.
Okay, so I'm going to stop right there. One of the things to note here is that if something is just random, of course, that is useless. So the in other words, if it's randomly up and randomly down, so the only thing that is useful is a probability distribution. So it's just
But she said some of them are
right. And so it exists in a superposition of up and down. So if it's both yes and no, exactly how is that going to be useful at all in the slightest? It's you're already starting to get into some magical ideation of just how do you use that in any kind of engineering fashion? Well, she's going through the same old way in which they always explain quantum computing. Let her go ahead now for me.
For example, it could have a 70% chance of being 0 and a 30% chance of being 1, or 80-20, or 60-40. The possibilities are endless. The key idea here is that we have to give up on precise values of 0 and 1 and allow for some uncertainty. So during the game, the quantum computer creates this fluid combination of heads and tails, 0 and 1, so that no matter what the player does, flip or no flip, the superposition remains intact. It's kind of like stirring a mixture of two fluids. Whether or not you stir, the fluids remain in a mixture. But in its final move, the quantum computer can unmix the 0 and 1, perfectly recovering heads so that you lose every time. If you think this is all a bit weird, you are absolutely right.
Of course you're confused because it's nonsense. There's a good reason why everybody who watches these same old things, you just basically they're asking you to take it on faith. Now, there's a natural thing whenever you're listening to a new explanation, you have to kind of take on faith that they're going to eventually get around to explaining the way that it actually works. They don't ever. There is no way that it works. And that's the problem with all these explanations is they're pseudo explanations. They're like, you might as well be listening to a cult's explanation of why it is that you should be drinking the Kool-Aid. They can give you a long bunch of information that seems like it kind of fits together, but at the end of it, it doesn't have any way that it really fits together and does something and is reliable and mechanical and fits with the rest of reality. And so what they're explaining there is, I like the idea of unmixing, because that's something I've been pointing out for a long time, because there is a way in which using you can't do it from here's the thing, you can't do it from a Copenhagen interpretation perspective. There has to be real states underlying these things for quantum computing to work. And that's what people are slowly getting to. And that's the way that this will work. If there is a real underlying state where the superposition of states is actually a mechanical mixture with a real determinate state and is not actually just probabilistic, if it's just 20% probability and 80% probability, and there's probability at each individual step, it's probability. It's not one or the other. And the only way you can unmix is if there are very specific things. So that's why it's that glycerin unmixing thing that Bohm used. That's pilot wave, okay? That's pilot wave interpretation. That's why that was Bohm's favorite example. That's why it's my favorite example, is that there's something when you have what's it called? There's a particular, to the glycerin unmixing is a way to Google it to look at it, but it's can't remember the name of the experiment. Anyway, so the idea is if it only looks mixed, but it's not actually random. In other words, it has real states underlying there, that the probability represents something real. Okay, in other words, just because you think of it as a 60-40 probability don't mean shit in reality, because reality is deterministic. If it's a 60-40 probability that somebody's walking across the street, you can look out there and there's somebody really actually walking or not fucking walking. It's not the probability is an abstraction of reality, and it can't exist on its own, and it can't exist without the things that it represents. And that's the thing, is that the only way that quantum computing can actually work is if there is something real underneath the surface. There's some real those probabilities actually represent something real. That's the way that quantum computing will work, and that's called analog computation. Whereas when they have been explaining all this time beforehand is all based on probability, and if it's just really truly actually probability at the base level, it won't fucking work, period. So whenever they have advances in quantum computing, it's because it's proving that Copenhagen interpretation is bullshit and pilot wave is the only view that makes any fucking sense. So let's go ahead and go forward.
Regular coins do not exist in combinations of heads and tails. We do not experience this fluid quantum reality in our everyday lives. So if you are confused by quantum, don't worry, you're getting it. But even though we don't experience quantum strangeness, we can see its very real effects in action. You've seen the data for yourself. The quantum computer won because it harnessed superposition and uncertainty. And these quantum properties are powerful, not just to...
I want to know how.
Right. That's the point. They don't say how. They just say it did. It did. How? Because in theory it should. We think it should.
But we had to have the results.
No, it doesn't. It ends up not working every fucking time.
No, but they have 97-3.
That's just an example. That's just that she's just pulling that out of her ass.
Not something the audience. Like the circular square or whatever. Apparently all of their results quantum computer. It won 97.
That doesn't even make any sense. It's just that's just. I'm sure it was some bullshit little thing that is utterly meaningless. It's you'd have to show me what the hell you're talking about.
That's what she said.
Yeah, well, so it's just set up to win. Yeah, I could set up something to win some theoretical game. But... Yeah, no, it was set up to win, and all it was is they just gave it a 97% chance to theoretically win in this completely unfair, stupid little game that they had people.
Picked,
yeah, it doesn't matter. Yeah, I can set up a game to that doesn't matter.
And the Rainbow went against that.
Right, how to go against it, decided whether it won or didn't. It was just like, I win.
No, it did heads or tails. Let's see.
Our security needs, our healthcare. So I can log into IBM's quantum computer from right here, which means I can play the game remotely, and so can you. To make this happen, you may remember getting an email ahead of time from Ted asking you whether you would choose to flip the coin or not if you played the game. Well, actually, we asked you to choose between a circle or a square. You didn't know it, but your choice of circle meant flip the coin, and your choice of square was don't flip. We received 372 responses. Thank you. That means we can play 372 games against the quantum computer using your choices. And it's a pretty fun.
What the fuck is a game about that? I don't see anything even remotely game about that. How is it a game? That doesn't, you just picked.
Your coin flip was a game.
Yeah. Like I said, this is just a bullshit thing. I'm telling you, it's just bullshit. It's just a demonstration that's meaningless.
For diseases like Alzheimer's. So, for encrypting, the quantum computer won because it harnessed superposition and uncertainty. And these quantum properties are powerful, not just to win coin games, but also to build future quantum technologies. So let me give you 3 examples of potential applications that could change our lives.
Because it's too much potential.
Okay, no, it's entirely bullshit. Okay, yes, that is the vague, hand-wavy, nonsensical bullshit that doesn't make any fucking sense that people usually spew out at you about quantum computing. That's it. That's the most you get. You don't get any. Exactly. There's zero how because they don't know how because it doesn't do it.
Well, they said.
Okay, it doesn't do it in the way in which they usually explain it. Is the point? There is a way for it to work, and but the way that it's explained is always based on that old Copenhagen bullshit.
For the first time, a team has sent a light particle entangled with matter over 50 kilometers of optical fiber. This paves the way for the practically quantum network, the milestone for quantum internet.
That's entirely different. They're just using the word quantum there. That's all. And entanglement is a whole other ball of wax. Okay, so oh god, see, you have to start everything at its when you start with the assumption, when you start with a magical assumption and then keep going and going and going and going and going and going, which is what they did in quantum mechanics. Okay, they started with assumptions of magic, okay, and then developed based on that. So they're talking about, you know, how much the number of joules of energy the fishing tree, you know, exerts to impact each neuron of the fish's brain, and you know you can take something that is a half truth and just really go on and on and on with it, and you end up with bullshit. And that's the problem. That's where we're at, is we have these things that are based upon bullshit assumptions. Like, okay, so now you have to talk about Bell inequalities whenever you're talking about entanglement, and this idea of how entanglement works, and whether or not there is this communication of two objects completely at any distance that happens instantaneously. So that's part of that's also part of the whole quantum magic shit.
Quantum computer, right?
Quantum magic shit
what
is what
even
it is.
Any of it.
And that quantum magic shit, and that goes down to definitions of words, like specifically what the fuck is non-local. what was the word non-local mean? And that's why you have to go back to something that you can fucking show with a real goddamn experiment, and something you can look at for real, and not just say, yeah, the experiment did this. How do I know it did that? Well, my sensors that I set up in a particular way, which and nobody else could see that, and are interpreting the data in this particular way, say that it did that.
She was talking about the IBM computer, so maybe I'll look into more of what
yes, there is
that's
yeah, okay, it's great. There is, so like I said, there's some level of computation, and then we can get into some things like quantum annealing, and there are real aspects that go along that are mixed very deeply and intricately with complete and utter bullshit. And that's why quantum computing was supposed to be, a new regime that was started and fully functional, 8 years ago. There was supposedly, or maybe it was 6 years ago, whatever. There was a time where they were talking about having these quantum computers that were, they were coming out, where it's a new age in computing, and not a fucking thing has happened because it's bullshit. Because they have some little bit of truth mixed in with a tremendous amount of bullshit. And it's because there's a lot of people funding it because of it started with bullshit and high hopes, and we're talking about something that will massively impact the world. So people are... Right. You've got a lot of people bullshitting because there's a lot of money to be had for bullshitting. But there is kernels of truth, and being able to separate the truth from the bullshit is the difficult part, and knowing where they're bullshitting and where they're not. So going back to what we were talking about with things like non-local, you have to have you could look at the Walker experiments, okay? Mike, I mean, name even Mike, holy shit. No. John? Good God, why have I suddenly forgotten his name? That's so weird. John Bush at MIT, who conducts these experiments with the walkers. Those droplets bouncing on the surface, technically, they have entanglement that is non-local. Okay, they exhibit these quantum behaviors, but they do so in a way where you're like, oh, that's what the fuck is happening. It's not magical bullshit like we've been conceiving of it. It's the fact that, okay, so what's non-local about it? Well, the fact of the matter is the droplet can't exist without the information in the waves that are incident on the next bounce of the droplet. Okay, right. So in other words, the motion of the droplet as it bounces from place to place to place in the corral, and its very existence, it cannot exist without those waves. It will rejoin the rest of the bath if it does not have those waves continuing to add to it. Well, it creates some of those waves. Those waves interact with waves that are already there and bounce back, and then that information that is incident upon the location of the next bounce, so waves coming from elsewhere, are part of the existence of that walker. Its existence is in two places. Just like you cannot separate a river, the water in the river, from the riverbed. Right. It's only a river when both of them are happening. But I mean, you can think of that's like, well, a dry riverbed is nothing but a depression in rocks. Okay, and water without that depression to guide it is just water on a floodplain, water into clouds, water every fucking where. It's not the same thing. It's only a river when you combine the two things. So the same thing is true of the walker. There's information from elsewhere that has to arrive for that silicon walker to exist. So its existence is therefore non-local. So that idea of non-local suddenly makes sense in a way that is rational, deterministic, mechanical, and you can track it down, you can use it, you can understand it. You're looking at some questions you want to address? Okay, so that's the point, is that there's these concepts like non-local, there's concepts like entanglement, and in going back to this idea of Bell inequalities, Bell himself understood that once you have de Broglie-Bohm pilot wave theory to overcome these certain ideas and problems that we have, it no longer applies. Okay, his Bell inequalities, I mean, he talked about it numerous times. It no longer applies. It's not applicable. Yet still today, people will talk about Bell inequalities like that's just absolute proof that reality is magic at the base level. It's because Copenhagen is this damn zombie that won't fucking die and won't go the fuck away, and it's this stupid magical bullshit.
Come back to Copenhagen.
It's always this magical thinking bullshit. And well, the reason why Copenhagen is there is because we abandon the ether and we believe in things like waves that don't have any medium. You can't have an action. You can't have a jog without a fucking jogger. You can't have something happen that without something being there for it to happen. You can't have an action without an actor. And so, so our idea that a wave can occur without a medium is what eventually led to Copenhagen having these other magical things. It was literally in 1905 that physics fucking broke. That was when it broke. When we decided, well, actually, it was 1907. Excuse me, it wasn't 1905. It was not. Einstein was just saying you didn't need to calculate it. It was fucking Minkowski who decided that constancy was a real thing that existed in reality, and we conjoined space and time into this this mathematical structure instead of and we did all of this craziness, this basically making reality have an additional dimension beyond 3 is tantamount to saying that there are infinite additional 3D realities that you can use. That's what a 4D reality ends up being. So he added a infinite additional 3D realities to make up for the problem of having an ether. Oh my God, let's use Occam's razor here, like everybody says. That's why we got rid of. That's the only, because there is no experimental reason to prefer Einstein's relativity over Lorentz Poincaré. I'm always going to mispronounce his fucking name. Lorentz Poincaré ether. They're mathematically the same. And so the only reason to prefer one over the other is to decide you don't like ether, period. You just don't like it. It's completely an interpretation. It's completely opinion. There is absolutely no experimental reason. And if anybody says Michelson Morley at this point, I'm going to have to smack them because they don't understand how it works. So because Lorentz ether actually is... Well, the Lorentz transform is about how light moves through the ether, and it actually has. It does. All of these things are related. So yes, you're right. I am digressing to a certain extent because this is all important. It's all related. I'm sorry. You're right. I'm digressing a lot here.
Pedantic.
But it's all required to understand how it is that physics went wrong. We started believing in magic.
But that's not what we're talking about.
But it is, because that is what quantum mechanics is based upon. I mean, quantum physics is where you get quantum computing. And why they're talking about magical bullshit and have some of it right and some of it wrong is because it's truth within a limit. There are when you look at experiments over and over and over with atomic structure, you will come up with a probability density. But as Schrodinger said, there's a difference between taking a shaky or out of focus picture and snapshots of clouds and fog banks. There's a difference between those two, and he was trying to point that out to people and nobody fucking got it. So yes, the reason is that reality is not clouds and fog banks. We're taking a picture with probability. That's because it's too complex of a phenomenon. With Bush's Walker experiments, you cannot predict where the walker is going to go because it's too complex of a phenomenon. There's too many inputs, and so you have to use probability. You have to use probability to guesstimate where one of those walkers is going to be.
How is any of that going to help us? I don't know.
Because you bypass the stochastic problems. The randomness.
The ratata problem.
Yes, the ratata.
The staccato problem.
Yes, you bypass the problems of the apparent randomness, which is just complexity. It's not really randomness.
What apparent?
The way that particles behave, because they have so many inputs. Just like
What does that have to do with computing?
Because, well, how is it that you do computing?
I don't know. You tell me.
the way that you end up. Okay, so the difference between the two regimes is that in one instance you look at waves and the way that they interfere, and when you look at interference patterns, something real comes out of that. Whereas in the other regime, what you're doing is trying to use probability, and there's only a certain level of value you can get out of combining probability densities. You can't, if you presume that at each point the probability is not representative of something you are ignorant of, because that's the difference between Copenhagen and pilot wave. is that in Copenhagen and all those ones, well, in quantum mechanics, etc., the idea that we're treating it with probability is just that's what's there. That's all that's there. There's nothing underneath it. Whereas in pilot wave, we still have to use probability because it's so complex, but we still know there's something underneath there. And if there's something underneath there, that something can be unwound, as she was saying, just like Bohm said when he was talking about the glycerin unmixing experiments, which you put the drop in there and there's implicate and explicate reality.
Yeah, but how does that help? I don't really follow.
Because now, once you have something that can get really precise all the way down to the Planck scale, so there is a wave has is really there, and so a particle's existence is made up of all of these various waves, and so a particle doesn't really it comes down to emergent particles. In pilot wave particles, their very existence is an emergent phenomena. In other words, waves have to come together to make that droplet bounce, right? So the waves have to come together from elsewhere to impact the droplet and give it the energy to spring back up into the air and fall again and continue
like
that.
A hand spanking the
Right, it's got to smack it over and over and over. And so there is something, but in effect, there is the wave particle duality can be understood far better through that set of experiments. You can see wave particle duality happening. You can see how the energy of the whole system and how the waves themselves are interlocked. So how does that end up with computation? Well, it's I can't really go into the details of it, because the point is that when you a little bit when you are combining waves, think about how complex a waveform you can create by combining different waves, and you create these different shapes. Well, each point along the crest of a wave, or that represents information, and how much information can be compressed into that wave has to do with the size of the substrate. So in other words, like if I tried to make a wave out of really blocky figures, it would be there's each one of them can only represent a number. Like if I try to make a wave with a graph, like graph bars. Okay, so I stuck like 5 graph bars together to make a sine wave. It would be a really chunky sine wave, right? Sure. And each one of those points would you could say, well, this is a 23, and then this is a 57, and this is a 93, and this is a, and so you could sit there and say that. But what if I used thinner and thinner slices of that? How thin could I slice it? That each one of them would be a little piece of information, right? If each one of those, if I slice those graph bars that I'm making, instead of 5, now I use 100 little graph bars, and now my wave is smoother. Basically, I'm trying to explain something about calculus here. So then, if I make it, the smoother I can make it, the more information is actually available and stored in that wave. And the more and not just that, when I make waves interfere, if that wave is truly made up of really, really fine pieces, then the finite little changes to that wave can be ever smaller and smaller. So basically the point is, the smaller the substrate, more granular the substrate, the more information can be stored on that wave down to, and if it goes all the way down to the Planck scale, then you've got a method by which, when you combine waves, it can store and combine information in a way that's just like the way that we combine ones and zeros, but the values that are nearly infinite in variation instead of just ones and zeros. So like when you're combining ones and zeros, there's pushing and popping. There's these things in the way that you calculate in a computer with ones and zeros. There's these special methods of combining ones with zeros that can do these calculation things. I'm trying to explain how you end up calculating it, on the level of a board with that actually has ons and offs. But instead of just ons and offs, if you have actually values, and those values that are nearly infinite in scope can then be just directly combined, instead of blinking on and off, but all at the same time. There are all these different values that are represented by each little point along this extremely granular wave can then be combined. What you're talking about is a massive amount of information that is simultaneously being computed. And that's what reality is doing. And that's why analog computing is so superior. And that's what they're attempting to do. The problem is being able to control it at a very fine level and being able to measure it. And that is what Google's quantum supremacy thing was kind of about, and how that they were able to basically, they've come up with a way to control the analog computation process and see it at each control it at these various little points. And that's why it is the superior regime. That's why they've actually made real advances, because what they're doing is based upon a theory that's understanding and not something that's just, you know, based on bullshit of like use multiple dimensions and, you know, probability. And, you know, there's very limited uses to just probability. But once you have the actual underlying mechanics of the thing that you're abstracting with probability, or you can make it work itself. Now, this is the other thing. So the first people to use a phonograph, for instance, they didn't really necessarily, they didn't have to understand that when the vibrations of your voice cut little grooves that are themselves vibrations they're not vibrations, they're just of different depth or of different shape along the thing where the needle is cutting into the record or the whatever the fuck it was they used to cut into with phonographs. But it knowing that and then putting another needle on it to then play it out, you don't necessarily need to understand all the stuff that's going on in between. Or for instance, whenever you don't have to understand electromagnetism very well to simply know that when I make this move here, this moves over there. You don't have to understand the stuff that's intervening, that there's electromagnetic spectrum, that when I shove electricity through things over here, these things over here move slightly and pick up the waves. So that's the transmission of electromagnetic waves, like Tesla originally, you know, started first using. That he didn't necessarily even have to understand what was in between, because you don't necessarily have to understand what's in between to make something work. You can still use it. And so the same thing is true of these various things where you've got this problem of being able to unmix. You don't have to know exactly the state of the mixed substrate to be able to use certain methods to have it go in, mix, and then unmix. So probably the only way I could better explain it from here would be that there is, if you had a crystal that when you shined light on it, it made a certain shape on the wall. Well, if you could create another crystal that would be the exact opposite of that one, that would make the light go through it and undo what the first crystal did, right? So if I did this, then if I put something in between those crystals, it would have a certain sort of effect to it. But there's basically the mixing and the unmixing is, I know, I'm trying to explain some things that are difficult, and how that you would actually do quantum.
You would have some sort of an effect.
Wow. Well, okay.
So descriptive.
An effect coming out the other side.
Really
even after it's unmixed, the unmixing process would spread out the intervening effect in a certain way. So so I got two crystals.
Okay.
One mixes up the light. It impacts a little image of Little Red Riding Hood. It's like whatever, and then it goes into the unmixing crystal. Well, the unmixing crystal will only have the unmixing effect on now. Normally, the light would just come through as a beam, just come on the wall, and you just see like a white spot on the other side, right? Because it got mixed, then unmixed, you know, because it was like all spread out into like a weird pattern. And this is not that crazy, okay? Just listen. The look on your face, man. I wish I could share that. We should have done this as a video podcast. It's the best. Okay, you get the idea of light going into a crystal, and it would normally like spread out in different directions, right? And then another one could capture it and unspread it out, right? So that's kind of like unmixing.
I don't know.
Well,
is there any other example? Can we go back to water? This light and crystals on that.
Even when you don't get the idea of a light going through a crystal, it shoots out in different directions, right?
I don't
and then you can capture them and make them stop
How do
shooting
you
out, right?
capture them?
With another crystal.
How?
Because the light goes into it and it changes the direction of it.
I don't know about that.
All right. The point is that if I put something in between them, so just for the people who are listening, in case they get it, even though you don't, that if I put Little Red Riding Hood in between the two of them, even though it's a white spot on the other side, what would come out the other side would not look like Little Red Riding Hood.
No.
It would come out.
Red Riding.
Because I don't know, it's just an image to have in their mind. A little something, a little fucking little. I don't know. That was the first thing that popped in my mind. It doesn't matter.
All the images in the world.
Oh no, little girl with a basket, right, running along. You know?
Oh my god, there's a basket too.
Yes, of course she's going to
grandmother's
grandmother's house.
Hood. This
No.
is a girl with a basket.
She's on her way to grandmother's house. How would she not have a basket? She's got to have a picnic basket. Come on.
Why?
Because she's Little Red Riding Hood, for fuck's sake. Oh god. Okay. So the point here we're trying to get to is the idea of unmixing. You don't necessarily have to know what's in the middle. Let me just at least say that. You don't have to know what's in the middle to be able to use a system that can itself go do a mixing and then unmixing. And that's what happens with the initial phonograph, is that you don't need to know the size of the little vibrations of the needle, and you don't have to have all it perfectly plotted out, just so long as you take the same phonograph phone that's listening to your voice and attach a dull needle to it afterwards, and then it'll shit back out the same vibrations that went into it, because of the fact that you're riding along at the same speed and the same number of bumps against that needle per second, and it'll end up creating the same sort of sound. And so that's the way the principles that it worked upon were not precise, but just as long as you conform to a certain set of circumstances, you can make a system do things in the middle that you don't necessarily perfectly track or know. And so that's part of the principles that could be relied upon too, with using these extremely finite substrates of electromagnetism. So anyhow, that's the point. It's analog computing. That's all. That's it. That look. It means that you're making waves interfere with each other and creating complex patterns. Those complex patterns represent data. That data, you can store a tremendous amount of data and make that data mush into the other data and get something out the other side.
Cool.
Yeah, there you go. And it happens all at once. Instead of doing one little tiny piece at a time, very pedantically, like a binary computer does, one little tiny itty bitty piece at a time, do it a big old fuck ton at a time. Just smashing the data together, because that's how reality does it. And you're basically by using analog systems, you are doing what reality does, instead of having this pedantic one at a time linear flow of information that you're constrained by that you have in digital computing. However, to make it useful, because there are issues with there are points at which all the variations that can occur, there's all these different engineering problems with electromagnetism coming in from various places and causing decoherence, and there's a lot of different engineering problems that are part of what they have to overcome to make it work. And so there's different ways that they're coming at the problem. And actually now that people who are really developing quantum computers are not using any of the bullshit ideas, they're using, they're actually trying to do analog computation, then it's starting to work now. And so we're about to see some massive fucking advances, in my opinion, and it's kind of now a race to actually create. Now, the people in my group, some of them were saying, well, they didn't do anything. The quantum supremacy thing, all they did is just prove analog computing could work. That's all they did. That's it's a very simple. The way that they describe it is not quite so simple, but it is. That's all they're describing, and that's all that they've done is just show the ability to do what nature does in a controlled and precise fashion. And that was the biggest problem with quantum computing before, is that you couldn't do with a model what nature could do. You could just try to model it, and modeling it with our linear methods would always take far longer than for nature to actually do it. Well, now we're doing it with nature.
No.
It's a, well, that's yeah, I know. We're doing the types of things that nature are doing.
What's
by
the thing about that? The way you explain that all to do with position.
It does, because okay, so the nature of, that's why I started getting into all the quantum mechanics of it, because the nature of what particles are, how they exist, what's going on with them, and why you can get all the way down to that level of granularity with the waves is because you have to have a theory about what's really going on underneath the surface there. Is it just all a big old pile of probability? Is it just a pile of is it just snapshots of fog banks and clouds, or are we taking a picture with a foggy lens and a shaky and out of focus lens? Yeah, we are taking a picture without a shaky and out of focus lens, just like Schrodinger was trying to make everybody understand. And because of that decides what your methodology, being able to understand what's going on with how particles really exist, decides what methodology will be workable and what will actually accomplish something. And that makes the difference between whether or not you're bullshitting with the prior using multi dimensions we use all the dimensions simultaneously to compute, and
right.
and all that bullshit. It's bullshit.
Because that we had, like you said, on the cusp of this great technology for like way too many years now. Nothing's happened.
Yeah, it's just gone absolutely fucking nowhere.
Right.
And
superposition quantum is really not.
Right, but part of that is engineering. Okay, so part of it is because of the methodology that they're using. What they've been trying to do is super cool things and make sure that no electromagnetic waves. They're trying to make an isolated system instead of just a closed system. What this means is that no electromagnetic waves at all whatsoever can get into this chamber and alter the outcomes of the various things that are happening between the atoms. Because what happens is, so when you have oscillators that are of the same frequency in their oscillations, and they are capable of basically communicating with each other, there's something called coupled oscillation, or it was initially called Huygens odd sympathy. And that is like Christian Huygens discovered as a clockmaker and one of our great physicists. Was he a clockmaker, or was he? I know it was something having to do with clocks. But he had a bunch of clocks on the walls, and he noticed that when you have a bunch of clocks on the walls, they will all their pendulums will end up synchronizing together. They'll either be in opposite phase or in phase together. And so what happens is, but they end up being perfectly synchronized instead of just barely off from each other. And so this sort of synchronization leads to coherence effects at the atomic level. And so like you can end up having a bunch of atoms act as though it is one big pulsating thing, and then it can start to, instead of being many things, it can act like it is one thing.
And that's not entanglement.
It's related.
So we can talk to our patrons. Quick question, lightning round.
Okay.
What the fuck are time crystals?
Oh.
I expect.
When I looked into it, yeah. Truthfully, I think anything that pulsates regularly over time is a time crystal. I think that it's entirely just bullshit, just 100% fucking bullshit. Because if something, by adding time to it, all you got to do is have an event happen over and over, and with regularity, and then what is a crystal? It's something that has regularity, right? And so
are my cat's bowel movement?
If they were regular enough, they might be time quasi crystals actually.
Oh.
So the whole point of a crystal is that it has regularity to it and some sort of regularity.
Oh, so they're saying because that was the question. Which one of the two halves of the word bullshit? Is it the time part or is it the crystals part? So it seems like in this case, the time accurate part, they're just calling something a crystal because it has a regular. But how
over
does
time.
that apply to what? Well, I mean, an architectural building has a structure over time.
It doesn't.
As people build it, like, what do you mean?
But it doesn't cease to exist and then exist over regular. I mean, in other words, there's no space in between, and so I guess there might be something that they're using as a pulsation. That I just wasn't all that fucking interested in it because because you can tell from the onset that it's just entirely somebody trying to bullshit their way into more funding, and it's just not. It's not valuable enough to really.
That's funny. We had somebody in chat just really frustrated at money grubbing ways of economic opportunism and exploitation of essentially causing funding.
Yeah,
for something
that's not real, right?
Right, and it just capture the public imagination, but doesn't actually have a working method.
Yeah, no, it happens all the time.
I think they're onto something.
Yeah, it does happen. I mean, that's one of the things I because a lot of times it goes with a lot of anti-science. I'm loath to agree, but I have to agree. There are times at which
because you brought it up twice now during this talk.
It's a fucking huge problem.
I didn't adulterate.
But the problem is that they're taking money away from things that where you really could be spending that same money on something that is very important and will produce something.
I will also argue that another point of all of this is that how are they supposed to differentiate between something that's valuable but fringe, like the Walker experiments, because the dogma of the
you have to completely restructure the way leadership works. Leadership has to be based on intelligence instead of based upon popularity games.
Because how are they supposed to know what to fund?
That's the whole problem.
Which thing to fund if there's like 80 new things and only one of them is a new actual theory, but then you have the guard holding down the fort.
Right, it's because you have power decoupled from intellect, and so that's the biggest problem.
That's not true in physics because you have.
Oh God, yes it is.
Intellect. Well, how do you define intellect? Because they're all just upholding the old model. They're all very intelligent.
Well,
knowledgeable.
There's a big
knowledgeable.
There you go. And how do you determine who's intelligent other than IQ tests? Actually, you need competitions. You need various types, a lot of different types of competitions, and then you have to be able to differentiate the different types of intellect, because there are people who are more autistic and their type of intellect is not as valuable as other types of intellect in certain circumstances, but it's more valuable in certain circumstances than other types of intellect. And so, yeah, there's a lot of problems that have to be solved there. But the biggest problem is we're not even trying. We haven't even started down the fucking path of coupling intellect with power. There's just zero coupling of the two. The only thing there is just being good at being a liar. You can just be entirely a fucking AI, and so long as you're good at lying and memorization and regurgitation of situation, you could actually create a talker, there's these different types of old AI bots that basically they look at the information being put into them. Yeah, not today's topic, but they look at the information being put in and just kind of try to capture and regurgitate the what they received reward for in a certain way from spitting out some mixture of what was just input. And so you can literally do that and create a good politician, because that's really all that they fucking do is just that is a very social ability to memorize and regurgitate information based upon the situations and reward. And so it doesn't even really have much to do with communication. It's really more about signaling. When it comes to the social interaction of humans, the words that are spoken are not as much for information transferal as much as they are for navigating and compliance, navigating various types of and testing for hierarchy and alliance and things like that. So the actual content of the words becomes mostly irrelevant for people who are those regurgitate and memorize and collate the various opinions. That's why a lot of times they won't even know when they're lying. People who are extremely social literally do not fucking understand truth. They don't have an idea of truth. They just simply have collections of what is true is that which rewards me for speaking at this moment, given the current social environment and the group and what their opinions are. And so speaking that thing that is truth because I receive reward for it. It feels good. It has the truthy feeling, because truth actually is a feeling to people. Yeah. But I mean, even whenever you have a mathematical truth, you get dopamine. You get there are these things there is a feeling of truth. It's just some people actually get the feeling of truth from things that are lies, and they don't really even understand that they're lying.
Thinking waves and synchronization.
What? Oh,
something about friction.
Yeah, so there's difficulties. I think what they're talking about is engineering difficulties when it comes to creating coherence in. That's why they have to do. Okay, so the most recent way of doing it, they're actually using Josephson junctions, which, by the way, that's the same. This quantum supremacy. Yeah, Brian Josephson, the guy who's the Nobel laureate who's in my group. They're using his. That's what he got the Nobel for. Okay. They're using that in Google's development and the quantum supremacy thing. So yeah, a lot of that has to do with they're talking about like reducing the friction and things like that. That they had to use some crap. What's it called? Thinking of superfluids and shit like that instead of what the fuck? The word's just not coming. But
I can certainly not help you with this. Yeah.
Superconducting. God, wow, that word was just gone. They were using superconducting as a method for setting up coherence between things because I didn't. You just kind of mumbled at me what it was that they were talking about with friction, electrons, etc. And whenever they're trying to, when they're trying to set up. You're trying to set up a system of coherence. There are various engineering difficulties to overcome, and one of them, and the way that they're doing it is through Josephson junctions. I think that's what. So there are engineering problems when it comes to the quantum computing thing, but it has to do with why you have to try to set up coherence, and coherence is all about waves, and it's all about basically making a system. Of various parts all communicate with each other in a way that can set up patterns of resonance and that will allow for basically it's about the accurate propagation of waves. When you think about this for a second, that's what is important about crystals and things like that is the way in which they can propagate waves in a very accurate fashion, in a very reliable fashion. But think about how if I had a bunch of random primitive shapes like cones and cubes and cylinders and other weird shapes, and I just stuck them all in a pile, and then I smacked it at one end. And how the wave would try to propagate through them, those various surfaces would make the waves go in weird directions, right? Right, and it would break up the wave into a lot of different directions. But if it was made completely out of cubes and all of them were perfectly together, and I smacked it at one end, well, then the wave would travel through that whole medium in a much more reliable fashion. So that's what the idea when you're trying to set up something that has to do with wave computation, you need those waves to be reliable, and that's why you have to set up systems of coherence, and that will basically make the waves extremely reliable at this tiny scale. And then the waves that you're using are can easily be disrupted or changed or impacted by electromagnetic interference, and so overcoming all these things is definitely part of the problem. But they've just, like I said, they've just overcome it with the Josephson junction approach, and then the but okay, so there's a I don't understand that technology very well. So I can't tell you very much about it other than that they're using superconducting as a way. Superconducting it allows you to conduct electricity without friction. So it's
hell is friction?
from an ether standpoint,
Yeah.
it's turbulence. Whenever
Ether turbulence?
yeah, basically whenever you've got so do you know what turbulence is? Turbulence is when if you have two systems of rotation next to each other, and those break into smaller and smaller and smaller vortices until you have a layer that is viscosity, and so
a layer of viscosity.
Big whirls lead to little whirls, feed on their velocity,
And
little whirls lead to smaller whirls and on it to viscosity. It's just a property of two larger things and how they can move against each other based upon the constraints of the rotations that are occurring in the fluid. So, yeah, so friction is related to that, and so what they're doing by using superconducting is basically allowing conduits through which you are basically reducing the gearing effect that is necessary. I don't want to get into it too much, but from an ether standpoint, I can talk to you about it later because it's something that's involved. But yeah, it's neat.
Then there's a brown.
Yep, exactly. So that's part of the shit they have to overcome with the is the when you get down to really small levels, you've got Brownian motion that is, and even talking about what exactly Brownian motion is a difficulty. It's just a magical effect without any mechanism. But with ether theory, it's the impact of nearby flowing ether, all the various subtleties of the vortex filaments that are in the ether are actually impacting the particle moving around, and that is it looks completely random, but it's not random. It's basically all the encoded information in the substrate is impacting it, but it's information we don't currently ever even talk about, think about, or look at because we don't believe that it's there.
So it's the wave and
it's part of it's part of the subtleties of what is cause of Brownian motion. It's the various subtleties that give the stochastic effects in quantum mechanics are occurring because of the existence of subtleties in the medium that are present, and so
we could actually get much further if we.
Oh yeah, if we actually accepted that there may be more information available, which is, that's all it does. Ether theory just simply gives us more information. It uses the same all the same systems. Everything's still the same. You can still use quantum mechanics. You can still use all the systems currently in place. You just get to explore where there may be more information. That's all. It's just that fucking simple. It's just there's more information available, but we're not exploring it.
I don't understand why also
because people don't understand the Michelson-Morley experiment. They don't understand. There's all these historical problems they don't understand.
And there's a cult of personality and areas of physics.
Right, they're all around Einstein for constancy, and he constantly said it's the
current ones,
yeah,
like Michio Kaku.
Oh yeah, God, don't even get me started.
Like all the talking to kids all ages about. Then observe it, and
At
then
point
it becomes
3
real.
and then it's real.
Whoa.
You make the universe. And at 0.3728 picoseconds into the Big Bang, there was exactly this amount of. We know this for certain because all of our fucking models are broken.
And we have this cosmic background radiation that we cited means all these things.
Oh god.
No problem. But that's where the confusion is, because many things in quantum are Copenhagen crash, but then other things are actually, as Schrodinger was saying, like,
well, there's a lot of experimental physics tied up in it, and that's
right.
the thing. You can just like when it comes down to the spirit of the fishing tree, the experiment of them beating the root into the water and fish rising to the surface is irrefutable. You can just replicate it, and it does it. It's just their theory's all trash and can't be used to fucking accomplish anything. And just a little change to their theory, and suddenly they may be able to. But unfortunately, those people don't have enough information that if you told them that it's a neurotoxin, what good does that do them? Not a fucking thing. There's a gigantic swath of information you have to give them for the word neurotoxin to be useful to them at all. And even then, they need all this equipment, all these other things. So basically, the truth at the level that they're using it is more valuable to them than the fact that it's a neurotoxin. And so that's sometimes true even of us in our current situation. We don't have enough information about what's necessary to apply all of the additional things that we could get from ether theory because we've just not been fucking developing it. We're like those Aborigines, in Papua New Guinea. We don't have a use for it yet because we haven't been investigating, we haven't been developing it because we've just been closing our eyes to it and believing in superstitious nonsense.
Yeah, that's what I was saying about where there's like so much personality, and because it's not a unified field. You have some people on the ground doing, like you mentioned, MIT, all the way back to, and you also have this other realm of just media related journalists, like science journalists, personalities, qualities.
Yeah, and people don't understand how much those people do. They do have an impact on scientists because those are
but also CERN and like
the
all
people.
The other...
Funding comes from popular science,
right.
Okay, and then funding determines the actual science. So actual science is determined by fucking popular science,
right.
And so people don't get that there's a cycle there it becomes a vicious cycle.
And sadly, the public imagination is captured with magic, because we've been trying to have science be magical for so long.
And it's so hard to get
and
scientists.
And it finally did, and it's not going anywhere. People are happy, but they're idiots.
Yeah, it's so hard to get people to understand like when you're talking to real scientists, as I frequently do. A lot of times they don't get how much we have to get the popular science fixed. They're like, I don't give a shit what the popular science, well, I don't care. I don't give a shit what all those idiots think. And it's like, you got to. You have to, because they determine eventually your funding. Right. Yes, they don't directly determine your funding, but eventually the word of mouth and the popular beliefs are what get around to the people who hold the fucking purse strings. That is eventually going to impact, and not even just the individuals, but the groups. They have to be able to, when they make a decision, even if you have a person at the top who is fairly intelligent, who isn't just going on popular science, but is fairly well informed, even they have their constituents to please, who are, guess what? They're saying, hey, what are you wasting our fucking money on this crazy science shit for? Fuck science. I want, this. And you've got all this anti-science going on. You've got all these people are saying, hey, all these science projects we're doing, defund science, fuck science, science sucks, because there's all these people faking it. And it's like, they point at the people faking it instead of saying, hey, they're stealing money from the most crucial goddamn pursuit of mankind. Instead they're saying, no, just fucking the solution to the problem of them fucking over the science funding is to get rid of science funding. Oh, no, God, don't listen to those fucking cavemen. Fuck them. Instead, this is the most crucial pursuit of mankind. It is how we have been overcoming all of our, a lot of it started causing our problems, but it's been overcoming a tremendous amount of problems as well. And we're at the cusp of a point at which I believe it will become a transformative point where the amount of problems it causes versus the amount of solutions it provides will suddenly be a gap that's widened tremendously. Right now, it's really not a very big gap, and people don't want to face that fact that our technology causes almost as many problems or more now. Actually, it's probably gone over the top since we're getting close to basically killing ourselves via our technology. But there's a point at which suddenly it will flip and go massively the other fucking direction, where suddenly the benefits of the technology will so vastly outweigh the deficits that they won't even be comparable. But right now, yeah, it's finally, for a while we were well ahead. We were ahead of the curve with technology being beneficial, but now we're at the point where they're not only gotten to equal, but technology is actually possibly going to destroy all of mankind if we don't progress through this transitionary fucking point where we have to overcome this orthodoxy and change the paradigm and actually rocket ahead forwards. But everybody's actually scared of moving ahead forwards, because if we move ahead forward too fast, somebody's going to gain a whole bunch of power, and there's going to be a one world government, so people are actually holding back. They're actually putting on the brakes when we're hanging over a fucking precipice. And people are slamming on the brakes in scientific development. They're like, oh, well, what if we make super intelligent AI? And what if we
There's a gap there, folks, that we gotta
we gotta get the fuck, because guess what? Somebody's already gonna do it. It's like, well, what if somebody develops the autonomous weaponry? Somebody's going to do that. So we need to be able to develop we need to be able to keep moving forward. So we develop all of the fucking defenses against it, because that's what happens with all these various new technologies. Is yes, when it first comes out and only a few people control it, it always gets misused, it always gets weaponized, it always gets used in nefarious fashion. But then once it gets disseminated, once it develops beyond a certain point, tons of people start developing defenses against it, because there is a dissemination of knowledge. And that is the premise of the scientific pursuit, is to disseminate knowledge so there isn't an asymmetry between people so much that bad people can take advantage without anybody having a defense against it. That's why you have to continue forward. You have to keep disseminating. You have to keep a free flow of information. So that's one of the things that I've been running up against, is seeing there are real people in high levels of government and high positions in government that are really serious about saying, hey, we need to stop this technology. You can't fucking stop technology. You can't, even if you controlled most of the world, you still wouldn't be able to stop it. But you sure as fuck can't stop it in other countries. And so putting the brakes on in your own country is the worst possible thing you can fucking do. And so there's just like seeing these people who are scared of because we are at a point where technology may be about to absolutely fucking explode, to the point where 50 years from now you won't even recognize the world, where it just be so goddamn different, and that scares the living shit out of people.
Keep going.
Yeah, because it's one of those things where we've been kicked out of the nest. Now it's either we either fly or we fucking hit the ground. We've already been kicked out. So we either fly, spread our wings, fucking start flapping, or go, oh God, I don't want to do anything because it's a very dangerous situation. It's already, you're plummeting. You got to do something.
Yeah, that's the unfortunate part of, like in a cartoon, finding yourself. You already went off the cliff's edge.
Yep.
And now we've realized.
You're like, I don't want to go off the cliff. I don't want to.
You're already there.
I don't like that. I want to go back to safety. You can't go back to the fucking safety.
It's like that movie also that, a really good movie about 2/3 of the way.
You know what? We're just like fucking a teenager just becoming an adult. That's what mankind is at when it comes to technology. Is that oh shit moment of having to do the adult thing, from being a teenager. Now, I'm sorry, I didn't mean to cut you off. What were you saying?
Moment is ruined.
Oh, I'm sorry.
No, it's like that movie we were watching that 2/3 of it was awesome and then it got weird.
Yeah, God.
You know exactly what I'm talking about.
Yeah, it was so bad.
So it's like that where at this point, cliff that we're off of, and of course a lot of people still believe that, well, we'll be fine because I'm fine in my house and there's some hurricanes elsewhere, so like that's how it's always been. Like it's
people always
fine,
think that
whatever.
There's nothing you can do about that.
People may not realize that we're off the cliff. That's the other thing.
Yeah.
And so the thing is, though, but for the people that you are talking about that are scared of how far we have gone off the cliff, the only solution there is to really dive forward and essentially figure out how, like in that movie, how are we going to live on Mars? Like to start embrace AI, embrace cyberization, just really like make humans space survivable,
and embrace the mistakes that are going to be made along the way, so that we can ameliorate the problems. Exactly. Know that there are going to be problems. Know that we're going to cause ourselves pains. We're going to make mistakes. We're going to fuck it up. That's true. Period. Get the fuck over it and start looking towards the solutions instead of worrying about the fact that there are going to be problems. And that's the biggest. That is that's just a huge difference between mindsets, is whether or not you try to just hide in a cave and be safe and never take any risks and therefore die because the cave collapses in on you and never get any food.
Or you believe that everything's fine.
Or you just believe everything's fine. Just stick your head in the sand and never believe anything's
and then what do you do with people?
There's not much you can.
No, but I mean, on one hand, it is a very survivable, adaptive attitude.
Well, you do need people who provide stability, and when they believe that there's nothing wrong right up into the end, they at least keep people calm to a certain extent. And sometimes that level it's fine, everything's fine, we're gonna be fine.
Let's just have some tea.
It's just gonna work out. It's gonna be fine. I mean, yeah, they cause complacency also, but they do cause. There's both complacency and stability.
It depends on how badly things are going, because if things are where things can be changed, fuck those people. Yeah. So right now, fuck those people. But we're quickly approaching the point where, hey, we need more people like you, because shit is fucked, thanks to you. But, you and your ilk. But we're going to be needing...
They're optimists.
Yeah.
They're optimists.
Right.
They're fiddling on the Titanic, like, let's continue to have tea and play our violins on the
You gotta have proper decorum, after all.
Absolutely. We don't want to be animals running for the lifeboats. My God.
So uncouth.
Uncouth, you panicky.
What would our
people.
Society think? We live in a society.
Really makes you think.
That reminds me, we do.
So, did you want to do something where we're doing an after show or something? Yes. Good. Do it. Unless you want to read one of my articles or something like that, because I thought you just had those linked. Okay, cool.
Yeah. On patreon.com/AnnaCherry. It's gonna be good.
Oh, well, those are.
Yeah, they won't necessarily be there.
Let's not.
But the information is gonna from them.
Okay,
there's gonna be a little Q&A in the resources section, because there are quite a few resources in. So you guys read a TLDR if you don't have time to listen, and we didn't necessarily go into detail about some of these things, but they're supplemental. But you can on your own time. All of that good stuff, that'll be linked on patreon.com/AnnaCherry. The posts will be public. If you would like to support us, check out Challenger Mode. If you want to keep things safe for work, for the most part, as much as it can be. Lewd, but not nude. And also join us for the after show, where you can lunge and go hardcore. But there's also beginner and challenger if you don't want to spend that much. And anyway, we appreciate it. So we shall see all again next week, ideally. See our patrons just a little bit. Bye.
Bye.